Hi, I'm Fearless here at PL, and I wanted to give an update on the Arduino controlled laser rig. So this is the first one, rig 1. It has all the diodes, the NumB 06 and I think it's the 08. Right here, the blue guys right there. I've got two of them. They're water cooled on top, and then they're PBS'd and come out with the cylinders here. And no spatial filtering yet because I'm trying to finish up all three rigs before I put the filters in. Over here is the red module, 6 Oculero 638 diodes. I'm running them at 1.4 amps each, and they're on a base plate that is cooled by a dual stage tech. So there are three dual stage techs, and when we go over to the other rig that's opened up, you can see. And then they have a custom water cooler that cools the hot side of the techs, and I'll show it to you on the other case. And then the beam combining mirrors, and then the cylinders to shape the beam, and then the space here is for the spatial filter. So and then a 6-watt CNI greenie. So, or 5-watt, sorry. So the way this works is you turn on the rig, okay, and it comes up with the laser rig control, and there's the Arduino and the MOSFETs that are have to be cooled by these big gigantic fins. Also over here is a PWM Adafruit board, and that allows me to control the diodes without attaching it to the DAC. And then right here is the 8266 Wi-Fi module that then will report to an OSC app or to a cloud-based system. That's not, the code is in, but it's not implemented because I'm trying to get everything down. So the laser rig control tells you, it actually measures the temperature of the initial rig. And if you, I'll show it to you on the other one, but if you can see, there are actually two probes here. These are called one-wire sensors. And then over here, there's another probe on the blue module, and also a probe right here that's attached to the heat sink on the water module. And that actually takes what the temperature of the water is in the water cooler. So the way this works is that you go and say quick start. So we'll hit the quick start. And what it does is it now starts cooling down the rig with text, and also turns on this very fast 7,000 RPM fan. And that's because it's all going to be put into a case, and the fan is there to both exit the hot air that may develop, but also for overflow purposes. So you can see that the blue laser diode is at 25 degrees Celsius, the case is at 25, and now the front and the rear techs are dropping in temperature. And I have implemented also a little timer. So it tells you how many minutes are left in the cooling down. And they cool fairly rapidly. So we're going to let them cool down just a little bit more, maybe to -10 before I start firing up the red. So I'm going to go over here and show you the inside of the case, and I'll just bring this over. Okay, so we've got the let's see. Okay, so these are the water cooling for the hot side of the text, and that's just the cooling for the blue modules. And you can see it goes through a really nice computer water cooling reservoir. It's filled with about 600 mils of fluid, and the fluid composition is 30% methanol, and that's to keep stuff from growing in. And I actually, when you come over here, I noticed that stuff was growing. I had to disinfect it. So the 30% methanol prevents that, and I also have anti-corrosion inhibitor in there to prevent the similar metal corrosion between the aluminum modules and then the copper module, which this guy right here, which stays on top of the stays on top of the blue LDs. Also, I'm using the Pangolin Scanner Max Galvos. I've got a picture of them right there. With the 8mm aperture, I really like them. I'm running Laser Fantasy amps, which are mounted here from Slick Lasers, and they work great. Not really. I have to do some minor tuning, but so far so good. I had them fired up yesterday, and they actually look pretty good. Again, here's the Wi-Fi module. These are Arduino boards. This one's from SparkFun. And then, so you got the cooling fans here inside, and the big fan up there. And then I have the blue is on a Wavelength Electronics controller for that, and then the reds have another controller to move the diodes. So that's the inside of the unit. So we'll go back over here, and one of the nice things, I put this on a Lazy Susan, and it's really helpful in positioning the diodes and then looking at them and moving the system back and forth. So back over here, you can see that the unit is cooled down. Now I can go back to the main screen here and go to RGB calibration. And this is a great little feature for doing alignment. So I'm going to just put it on half thing. It tells you what the voltage modulation is, and then you can play around with it. Obviously, I don't do this at full power. I basically will do the alignment way down to almost next to nothing. That way, like for example here, that's about the power I would do for doing the red alignment. So that's about it as far as controlling modulation based on temperature. That's a difficult proposition, because that would actually have to do with changing the mod voltages coming off the DAC. It would be much easier to actually change things with the laser drivers. I do have a safety feature, which is, I'll implement it here. If you, since I don't have any diodes, but I'll turn this on, and the safety feature is if you heat things up too hot, let's see. So I don't have any diodes here. I'll put a, so it should kind of, well, anyway, got to see. Normal operation. Okay. Should have done it. Anyway, it has an emergency cutoff. For some reason it wasn't working, but it's working on this. Anyway, great scanner amps, great stuff from Slick Lasers. I also have in the main screen, we can go and control it manually. So I can control the text manually and also the fan speed manually. And then I can load and save the values, go back to the main screen. Going to normal operation, I'm actually going to turn everything off and text and shut down. I'll go back here to the manual, see if I can control, yeah. So I can control the fan speed and the text. And this is really important because although the texts are running on PID, one tech influences the other one, so I don't know sort of the ratios between the techs and trying to drive them differentially. But this will give me an information, and then I'll put that back in the software. The software is over here, and I have it. I know most people are not going to figure this out, but this is the one-wire temperature probe addresses. So the nice thing about the one-wire system is that you can gang on as many temperature probes and put them all on the single bus, and you just address it all in software. So again, this is the software. This is I got a ILDA test from Ed Keefe. I haven't implemented it yet because I need to put in a couple of DACs to do that. But I thought I'd give you guys a little bit of a test or a flavor of what I'm doing. Talk to you soon, and remember the NewLem 4 meet is in October. I'll have all 3 rigs going by then with cases. There's the first one, there's the second one, and the third one yet to be built. But for the most part, the software is working, except for the Wi-Fi or the recording module. And talk to you guys soon. Thanks.